If water is poured into a conical glass with a height of 11 centimeters and a radius of 3.5 centimeters at a rate of 64.5 cubic centimeters per second, at what rate is the water level changing when the radius is 2 centimeters? Here I have the conical glass with the exact dimensions in the problem. I've measured out 200 cubic centimeters of water using this for the problem. And now I'm going to empty the water into the glass upside down while sliding this off so that it goes in at a constant rate. Let's do this. And it might have been hard to see, but it slowed down as it approached the top because the race is expanding. Okay, here's our solution. From the original problem, we know that we have to find dH over dt. So we draw the diagram for the cone, and we have the volume equation for the cone. We want to have only one variable h in addition to the v, so we need to find what r is in terms of h in terms of r. We can use ratios, so we found that r is equal to 3.5 over 11h, and we found what the height was at the point where the radius was 2 centimeters to find our new volume equation, plugging in h for r, and we rewrote it to make it simpler. And our next step will be to take the derivative. We can plug in our values. We know dv over dt from the original problem, and we have our new h from when we did the ratios, we found that. And then our next step is just to divide by everything in order to find dH over dt, and our final answer is dH over dt equals 5.086 centimeters per second.